Hello, my name is Yang Li. I'm the AP teacher here. And today we're going to discuss more about the derivatives and continue from the last video session. Today we're going to cover the example 3.8. This is a chapter opener, okay, estimated rate of the change of the velocity here. The story is this: the car, this is a very fancy car. They can jump the velocity very fast. They can accelerate. Actually, they can accelerate it very fast. Okay, they to give you the data like this. They said what from 0 to 60 miles per hour, right? Is it 0? Is 0? That's at the beginning. The velocity is 0, and then give them this 3.05 seconds, there will be what? 60 miles per hour. But here the question they would like to change to the feet per second, okay? So if you want to change the feet per second, let me show you how do they get this transformation of the units first, okay? So this is the commonly used. For example, you have like 60 miles per hour, right? So you can write like this. You can write it as well, 60 miles, right, per hour, like this, okay? Now, our job here is this. We need to change the miles to feet and hours to seconds. So what we're going to do is this. We time by what? We time something, the conversion, okay? Because I want to get rid of the miles, so normally I can put the miles at the bottom, okay? And I put what? The feet on the top. You see here, 1 mile, right? The mile. And then 1 mile equals equivalent to how many feet? 5280. So from here, you can see that this one can cancel. So if you use the 60 times by 5280 feet, you will get that many feet per hour. But we're gonna get rid of the hour to the minutes, right? And then seconds. So 1 hour, because I want to get rid of the hour as a denominator. So here I gotta put hour as numerator, okay? So I can get the hour as a numerator now. So we're gonna have 1 hour. You're gonna have how many minutes? That's 60 minutes, right? That's 60 minutes. So you can have what? Hour cancel. And then you gotta change the minutes to seconds because the minutes at the bottom here, so I gotta put the minutes on the top. 1 minute, 60 seconds. So minutes cancel. And then right now, you can see that you simply use your calculator, okay? I'm using 60 times by 5,280 divided by 60, divided by 60. We do this calculation now, okay? We can use graphing calculator or any calculator, okay? 60 times by 5280 and then divided by 60 times by 60. Go 60 times 60 at the bottom, you should put the parenthesis, okay? So follow the order of operation. So you will get 88 feet per, see here, this is the feet per second. See that? That's why they got this one, okay? So we can use this method to do all the conversions first. So we can change all this data from here all up to here until here, transfer to this table now here, this table, okay? Now, what we're gonna do next is we need to find what, because they ask you find what here? That's the rate of which the car is accelerating or appears to be increasing or decreasing or constant. They're looking for acceleration right now. So in physics, we knew that acceleration is what here? Actually here they are doing is what? Average acceleration. Because you take a function velocity, right? And then change of the velocity, that's the acceleration. So what we can do is this here, because they ask you here, they ask you what? Now computing average acceleration of the car in feet per second on intervals from t to 19.96 seconds. So what we're gonna do is this, acceleration, of course, this is average, average. So that's one equals what? Equals to Vt minus V 19.96 divided by T minus 19.96. Okay, you got this now, right? And then we know here, we can find a Vt minus this one, right? This one equals this now. So you can have what? 337.19 divided by T minus 19.96. Okay, so we will get this now. This is the average acceleration at the time t. That's what they got here on the table here. Okay, it's on the table here. But how do you get a 0? At the t equals 0 means V0, right? V0 we know is 0. So I just calculated one of them first for you, so you can get the others by yourself, no problem. So how do you find the acceleration of 0? You need to do is V0 minus 337.19 divided by 0 minus 19.96. But V0, we got the charge from here. From here is here. Vt equals 0, V0 is 0. So this one is 0. So we can simply do the calculation like this one. This one can put as a 0 here. So we do this calculation. You will get what? The acceleration of here, 19.89. All right. So that's the way we do this one. So you can do the other one here, for example, if you want to find, do one more for you, okay? So you get t equals what? 3.05, right? So you need to find a v 3.05, the velocity at that time, and a minus 337.19. And then we divide it by 3.05 minus 19.96, like this. Put parentheses there, okay? Now you need to determine what's this first. This one we got it from the table before here. At the 3.05, the velocity is 88. So we can change this question to, you see 88 minus 337.19 and divided by 3.05 minus 19.96. Okay, we can do the calculation, but it's a better way is this one. Put parentheses there first, okay? Because the graphing calculator is set up, programmed with order of operation, right? So you're gonna put 88 parentheses minus 337.19. And then we divide it by 3.05. But don't forget to put parentheses at the bottom also. 3.05 minus 19.96 closing. So we will get what 14. Here we got what 14.736. You see here? That's it. That will be the acceleration is this one out here. This one. 14.74. You round it up to the 100th place. And for the rest of the number, you can see, you can get it also, right? So now, after we got this one, we can answer this question now. So how do you answer this question? We have what? The rate of at which the car is accelerating. You see, accelerating is getting what? At here is the highest acceleration. And later on, it's getting lower and lower, right? So the rate at which the car is accelerating is decreasing as its velocity approach to 229.9 miles per hour. Because at this time here, because this one here is 337.19 feet per second. Around that time, that's the velocity, and then the time is 19.96. So when the time approached to 1996, that time, the acceleration is actually getting still positive acceleration, but just what? Increased, accelerated at a lower pace. Okay, so this is the question about this. And then we'd like to work on a little bit more with the 3.9 here right now. 3.9, they told you this story is this. They have a temperature here changing at 9 o'clock, the temperature is this, okay? And then at night, lower to the 60. And then back to the 7 o'clock, they go back to 70 again. This AM, this is PM, okay? Now they gave you the function of the time, temperature change along the time, right? And where T is the number of hours past 9 p.m. So T, for example, T equals to 2, the time should be what? Equivalent to 11 p.m., okay? That's the meaning about the T, because T is starting from 9 o'clock, you count the time. 1 hour later is 10 o'clock p.m., that's T equals 1, like that, okay? So right now, they ask you find the instantaneous rate of change of temperature at the midnight. Be careful, midnight. Midnight is 12 a.m. 12 a.m. means T equals what? 3, okay? So that's why they have a derivative of the function at T equals 3. Definition under the 3.5 equation, you have this one, right? That's easy, huh? And then what are you gonna do? You simply plug it in. Let me just erase it, okay? So we can see that better here. So T is what? This one. I put it here, right? And the minus T3. How do you get this number? You simply plug in T equals 3, you can get it, all right? So you're gonna have like this one here, you're gonna have 0.4 times by 3 squared, right? Use a calculator, minus 4 times by 3 and a plus 70, you will get 61.6, exactly this one, okay? And then you simplify, you can get this now. The challenge part is from here. Right now, from here, how do they get from here? You simply factor the 0.4 out, okay? After you factor this one out, this is T squared minus, be careful here. You factor 0.4 out, so this one should be 4 divided by 0.4, you're gonna what, 10, right? 10t. Why 10t? Because 0.4 times 10 equals 4, right? And then this one, you're gonna add by 8.4 divided by this one, because you factor this one out, right? So 8.4 divided by 0.4, you get 21. Now, this part you can use the formula we learned before is t times t will be t squared. This 21. 21, you can change it to 3 times by 7 because this is 10. But this is positive 21. If you put 3 and 7, you cross multiply, add together, you get positive 10, not negative 10. So that's why you need to put negative here, negative here. You see, t times t squared, negative 3 times negative 7, 21. And then when you cross multiply, will be 3t plus negative 3t plus negative 7t, you got negative 21t. So that's, oh no, crazy. So negative 3t plus negative 7t equals negative 10t, right? Match with this one. As what I mentioned before, use this for your methods to do factoring, you write it horizontally. So this one you can write it as what? T minus 3 and t minus 7. And this one you still have 0.4 in front. So that's why they got this one. And then the bottom one you have a t minus 3. So you can cancel this 2. So you will have this now. And then plug in 3 inside here. 3 minus 7 is negative 4. Negative 4 times this one is this one. Negative 1.6. Right? So, and you see here, many algebra skills, especially the factoring skills here, used a lot for the several questions. So from there, we can see that instant rate of change of the temperature at midnight is what? It's negative 1.6 Fahrenheit per hour. It means every hour, the temperature decreased by 1.6 degree Fahrenheit, okay? So today for this video lesson, we stopped it here. Next lesson video, we will cover example 10, 3.10. Okay, so if you have any questions, please let me know. Okay, okay, thank you. Okay, bye-bye.